All right, guys. So today we're going to go over slopes and equation of lines, which we know you've seen before here in my class, but we're going to go through this again. All right. So starting with slope, we'll go over the basics here. Slope, also represented by the letter M. Remember, that is our rise over our run, or if you like it symbolically, change in y over change in x. That's what the little triangle symbols. That's delta, change in y over change in x. And we use our formula of y2 minus y1 over x2 minus x1. All right. So rate of change, all those good things that go with this, that's what we're going to use for slope. All right. And if you remember, there are four types of slopes. We have positive slope, which goes up to the right. We have a negative slope, which goes down to the right as you go from left to right. We have a zero slope, which is our horizontal lines, and we have undefined slope, which is our vertical lines. All right, so hopefully you remember all this from Algebra 1. Now, parallel lines. What do we need to know about parallel lines? Well, parallel lines are lines in the same plane that do not intersect. However, how does that relate to slope? Well, slope for parallel lines are lines that have the same slope, but different y-intercepts. For example, we have y equals 2x plus 3 and y equals 2x minus 5. You see that they both have the same slope, but different y-intercepts. So that means they are parallel. The next thing we have perpendicular lines. Well, perpendicular lines are lines that have slopes that are opposite reciprocals. So lines that have opposite reciprocal slopes. So, for example, y equals 5x minus 3. So the opposite reciprocal of that would be y equals negative 1/5 x. And then, of course, your intercept doesn't matter at this point. I'm just going to go ahead and put plus 3, but it doesn't matter. They could actually have the same y-intercept as long as the slopes are opposite reciprocals. So if we're talking like 5, you got negative 1/5. And we're talking about like 2/3, it'd be negative 3/2. So make sure we have that incorrect. All right, so now we go to our equations. Now, we have three basic equations, if you remember from Algebra 1, of how to write a line. The first one is point slope. And if you remember, point slope means we have a point on the line and some slope. And what we want to do with that is go y minus y1 equals m times x minus x1, where x1 and y1 is my point, and of course m is my slope. And we never plug anything for x or y in, because of course we always want that. The next thing we have is slope-intercept form, which we're all very familiar with. That is y equals mx plus b, where m is my slope and b is my y-intercept, hence name slope-intercept. And then our third form is standard. If you don't remember from standard, that is ax plus by equals c. And so what we're going to do here, we're going to ask you to put given a point, given a slope, or 2 points, or whatever, we're going to ask you to put the equation of line in all three forms. So what we're going to do is start with point slope, go to slope intercept, and then change it to standard. You've done a lot of changing from standard to slope intercept point in the past, but we're going to do it all three ways. So let's take a look at an example here. We get m is 2, and it goes through negative 1, 1. So what this is telling us is that we want to find the equation of a line where the slope is 2, and it goes to the point negative 1, 1. So we're going to start off, as always, we're going to start in point slope form. So we're going to go point slope. I'm going to put PS for point slope. And so if you think about it, guys, we have an m. Well, here's my x1, and there's my y1. So I'm just going to plug it in my equation. Y minus y1 equals m times x minus x1, which would be minus 1. So y minus 1 equals 2 times x plus 1. And that's what I'm going to write as my final point slope. And that's all I have to do for point slope. Just plug it in and let it sit. To get the slope intercept, what I'm going to do is I'm going to change my point slope and I'm going to convert it to y equals. So I'm going to just solve for y. In this case, I'm just going to work from here. We're going to distribute my 2 first. So I'm going to get y minus 1 equals 2x plus 2. And then I'm just going to add 1 to both sides. And I see that I get y equals 2x plus 3. And there is my slope-intercept form. I'm going to abbreviate that SI. So y equals 2x plus 3. Now, to get standard form, if you notice our standard form from beforehand, it's ax plus by equals c. Basically, guys, what do you notice? The x and the y are on the same side. So all I'm going to do to get my slope-intercept form to standard form is I'm going to just move my 2x to the other side. So I'm just going to subtract 2x from both sides. And I end up with negative 2x plus y equals 3. And that's fine right there for standard form. The only thing we ask for standard is that you don't leave any fractions. Okay? Just don't leave it in fraction form. Go ahead and calculate the fractions, multiply by common denominator. But that's the only thing we're asking you to do extra on this. As you get further into math, they actually don't care about standard form having fractions or not, just as long as it's in that form. All right. So let's move on. Let's do another one here. This time, they give us 2 points. Instead of a slope and a point, they give us 2 points. So if you think about it, guys, we need a slope to start anything out with point slope, slope intercept. They both have slope in it. So we need slopes. The first thing we do is find slope. So I'm going to go M, and this is going to be, I'm going to go x1, y1, x2, y2. And it doesn't matter which one you choose to be x1, y1, x1, or x2, y2, as long as you're consistent when you do your formula. We got slope. So it's the difference of my y. So I'm going to go 2 minus 5 over 1 minus minus 2, or 1 plus 2. So that's going to give me is negative 3 over 3, which is negative 1. So my slope is negative 1. And now I can do my point slope and slope intercept. So starting with point slope, I'm going to go y. And now, because you have 2 points, you can choose either point to do it. It won't matter. It'll come out to be the same regardless. So I'm actually going to write both equations, and then I'm only going to work one of them. So you can, we did x1 and y1 as negative 2, 5. We should get y minus 5 equals negative 1 times x plus 2. If you use the other equation, you would get y minus 2 equals negative 1 times x minus 1. And either of those would be acceptable. So you don't have to worry about, oh, I have to pick the right one. No, that is your answer. One of those would be fine. All right, then we're going to go to slope-intercept form. Well, I'm just going to take the second one, y minus 2 equals negative 1 times x minus 1, and I'm going to go from there. So I get y minus 2 equals negative x plus 1, add 2 to both sides, and I get y equals negative x plus 3. So there's my slope-intercept form. And I'm good there. And then I'm going to change it to standard. Means I'm just going to move my x over. I'm going to add x to both sides at this point. And I get x plus y equals 3. There's my standard. So you see how easy or simple this can be as long as we're following our steps correctly. All right, so now let's add in our parallel and perpendicular. We're going to ask you to do things with that. So in this case, it says find a line perpendicular to y equals negative 2x plus 2 that passes through 2, 3. So let's think about it, guys. We need to find we're going to put this in the slope-intercept form. But again, we're always going to start on standard. However, what do we need for, not standard, point slope. So what do we need? We need our slope of our line, and we need a point. Well, we got the point. Point is x1, y1 is right there. It's 2, 3. That's our point. However, we're looking for the slope of a line perpendicular to the line given, which means my new slope in all this is the opposite reciprocal of negative 2. And so the opposite reciprocal of negative 2 is 1/2. So now I have my slope. I have my point. We can now do my slope-intercept, or my point slope, and then convert it to slope-intercept. I'm going to go point slope. So I get y minus 3 equals 1/2 times x minus 2. And now I'm just going to convert that to slope intercept. So y minus 3 equals 1/2 x minus 1, add 3, and then my final answer is y equals 1/2 x plus 2. And there's my equation. That line is perpendicular to the line above it. The slopes are opposite reciprocals, and it doesn't matter that the intercepts are the same. That just makes it easy when if we had to graph them. They both end up on the y-intercept of 2. So let's look at the next one here. The next one tells us that we want to find a line parallel to y equals 3x minus 5 and pass through the point 1,5. So again, we have our point. Here's my x1 and y1. And then my slope. Well, since we're parallel, you know my slope has to be the same. So my slope is 3. So let's go ahead and put this, find our point slope. Y minus 5 equals 3 times x minus 1. And then we're going to convert it. Y minus 5 equals 3x minus 3. Add 5, and we get y equals 3x plus 2. There is my new answer. And we see that y equals 3x plus 2. Is it parallel to y equals 3x minus 5? And we see, yes, it is. They have the same slope, and our y-intercepts are different. So it follows what our definition was earlier. All right. Another question. This is one you are going to see, and you're probably going to see this on your test and quiz as well. Perpendicular bisector. And think about the name, perpendicular bisector. What does that have to be? It's got to be perpendicular, and it has to bisect. And since we want to find the equation of a line that is perpendicular bisector of a segment that passes through 1, -3 and 5, 7. Okay, so we have a line that goes through these 2 points, and we're trying to find the perpendicular bisector of this segment that goes through that touches 1, -3 and 5, 7. So a couple of big things here. One, we have to find slopes and then find the opposite reciprocal. Then, since we are a perpendicular bisector, we got to find where does that perpendicular bisector meet the segment, which means we got to find the midpoint. So a couple of different things here. We need to do slope and we need to do midpoint. So if we remind ourselves, let's write this out real quick. Slope is y2 minus y1 over x2 minus x1. And if we think about it, midpoint, that is my average of my x's, comma, average of my y's. Okay, it's a coordinate. So let's find our slope first. Let's go with that. My slope. The slope of the line they just gave me is 1, -3, 5, 7. So let's think of x1, y1. Let's go x2, y2. So we're going to go 7 minus a -3 over 5 minus 1. So that gives me 10 over 4, which is 5 over 2. So that's the slope of the segment we're looking at, but that's not the slope of the line we want. The slope of the line I want is going to be the opposite reciprocal of that. So the slope I'm looking for is -2 over 5. And I'm going to box that in because I know that's what I want to use. It's -2/5. So that gives me the slope of the line I want. Now I need to find the point that it passes through, and so that's where I'm going to use my midpoint. So using my midpoint, I'm going to do my average of my x's and average of my y's. So I'm going to use the same 1, -3, 5, 7. So my midpoint that I need is going to be 1 plus 5 over 2, comma, -3 plus 7 over 2. And it ends up being 6 over 2, comma, 4 over 2. And if we reduce that, it's 3, comma, 2. Fix that 4 up for you. So now I have my point at 3, 2, and I have my slope at -2/5. I can now find my equation of my line. So we can go through point slope here, all right? So we got y minus 2 equals -2/5 times x minus 3. All right, so from there, We're just going to distribute, solve for y. Y minus 2 equals negative 2/5 x plus 6 over 5. Add 2. So I'm going to add 2. Now remember, if I'm adding 2, to add it to 6 over 5, I got to get the common denominator. So instead of being adding 2, how about 10 over 5? Make a fraction. And so at that point, I now end up with y equals negative 2/5 x plus 16 over 5. And since I don't expect you guys to turn into decimals or anything, we can just leave it like that. All right, and that's perfectly acceptable for us. All right. So you see here, again, recapping, perpendicular bisector, you have to find the slope perpendicular to the points given to that segment. And then we got to find the midpoint of that segment so we can figure out the point that the perpendicular line is passing through. And then using that slope and that point, we can then solve our equation. So, of course, we end up again with y equals negative 2/5 x plus 16 over 5. So if you have any questions, you need me for anything else, please come see me later, and I will see you next time.